All right, we are going to bring together all of the ways that we have solved our quadratics. Well, most of our ways that we've solved quadratics. We're going to be talking about all the ways that we can solve these things by hand, dealing with factoring, our square root method, and then also quadratic formula. So it's a little bit of recap from there. So those are 3 methods that we're talking about. And a lot of these methods we talked about in Unit 7, Unit 8, and then quadratic formula in Unit 10. Quadratic formula. We're going to be talking about some things that you can be on the lookout for, just to give you some tips and tricks on which method to solve. A lot of times I think if you have the ability to factor away, just because that tends to be the most straightforward. And we've been practicing factoring so much, you probably dream about it. So let's talk about our first one. With all of these, we're going to get everything on one side, not with all of these, but with most of these, we're going to get everything on one side. So we're going to add that 18 over, and we have that x squared plus 9x plus 18 is equal to 0. So when we're factoring, we set everything equal to 0, and we can factor that quadratic. A lot of times we have an a value, we have a b value, we have a c value, and then we are able to look for our 2 numbers. Our 2 numbers that multiply to 18 and then that add to 9. So creating those 2 parentheses and thinking about all of my factors of 18, right? So like 1 and 18, 2 and 9, 3 and 6. Well, that makes 18. That also adds to 9. So we have x plus 3, x plus 6 is equal to 0. X is equal to -3, and x is equal to -0. You would have gotten both of these solutions if you use the quadratic formula, but personally I think factoring, if you have the ability to do so, is the most straightforward way to do that. All right, talking about our next one, we have everything set equal to 0 already, and we have this 2 expression quadratic binomial. So when I'm looking at these 2 expressions, these 2 terms, I see 2 things in common. I have a 5x or a 5, and then also an x that I can take out of both of those terms. When I rewrite that expression, 5x squared divided by 5x is x, right? We have that left over. -10 divided by 5, -2, x divided by x, right? Those cancel. So I have that factored form, right? Then I set both of those parentheses equal to 0 and solve, right? Easy peasy. We get x is equal to 0, x is equal to 2. No need to take square roots of things or simplify numerator, simplify denominator, right? We have that lovely factored form. And then our last one, we have yet another quadratic binomial. With this one, it is a little bit special, just because when I'm looking at both of these terms, there's nothing in common for me to take out. But when I'm looking at this first term, I have that 16x squared, the square root of that is 4x. When I'm looking at that 9, the square root of that is 3. So I can factor this as a difference of perfect squares. Take the square root of 16x squared, take the square root of 9. The only thing that changes is flipping the sign between both of those expressions, and then I could set both equal to 0 and solve. I get 4x is equal to 3. Subtract 3, divide by 4, -3/4. So those are my 2 solutions. All right, this next one is probably a huge recap. We haven't really solved using our square root method for a while now, but we're going to review a couple of these types of questions. So we're going to use this when there is an x squared term, but there is no x term, right? When there's like an a term, but there's no b term. So looking at our first expression, right, I see an a term. There's no x, right? So, or there's no b term, but there is a constant, or that's c. So that being said, we can use our square root method. We focus on getting just that x squared by itself. So we'll add 15x, or 15 on both sides, divide both sides by 2, and get x squared is equal to 15 over 2. Take the square root of both sides. We get x is equal to positive root 15 over root 2 and negative root 15 over 2. Now, if we remember back in the past about simplifying this radical, we don't like that there's a radical in the denominator. So this is another review little extension. To get that radical out, we multiply both top and bottom by that radical root 2. So numerator becomes root 30. Root 2 divided by, or multiplied by root 2 is 2. So our two solutions are positive root 30 over 2 and negative root 30 over 2. Those are the same. This is the same as that. It's just written. This is technically the most simplified form. So our exact answer for this, root 30 over 2 and negative root 30 over 2. Rounded value, plug that into your calculator, you get 2.74 and negative 2.74. All right, so in this next one, we are looking at this expression again. I'm seeing that x squared term, but I'm seeing no x term, so I'm thinking square root method, right? The whole point is to isolate that x squared value. So what I'll do is I'll subtract that negative 4 on both sides. I'll get negative 3x squared is equal to 6. Divide both sides by that negative 3. X squared is equal to negative 2. Then at this point, take the square root of both sides. Oh boy, we don't know the square root of negative 2. In fact, there is no real square root of 2, real number, right? Real solution. So we have no solution. This quadratic will not cross the x-intercept or x-axis. We'll have no roots. We'll have no solutions, and we are done. All right. Got a couple more examples with this. Again, we see our x squared term and we see no b term or x term. So we'll just divide both sides by 6, isolate that x squared, and then look to simplify that square root. Again, this is a big recap. Take the square root of that 20, and we want to simplify that radical. Largest perfect square that divides into that 20 is square root of 4. Square root of 4 times square root of 5. So we get 2 root 5. Positive 2 root 5 and then also negative 2 root 5. Our rounded value 4.47 and negative 4.47. 7 is probably one of the trickier ones just because it involves simplifying our radical and then also dealing with all this junk within our parentheses. This is the whole term, this whole expression is what we want to isolate. It's not just an x squared, it's that x plus 8 in parentheses squared. So let's subtract the 10 and we get x plus 8 squared is equal to 32. Take the square root of both sides, and we get x plus 8 is equal to both positive and negative root 32. Looking to simplify that further, we're looking to find the largest perfect square. Square root of 16, square root of 2, which simplifies to 4 root 2. That x is not isolated yet. We still have that positive 8. So subtract the 8. We get x is equal to negative 8 plus or minus 4 root 2. So our exact value, -8 plus 4 root 2, and -8 minus 4 root 2. I know those values look gross, but those are our exact values. Our rounded, -2.34 and -13.66. All right, so those are all of our examples of the square root method and a little bit of recap of factoring. Let's head to the back side and do some practice with both factoring and square root method before I set you free to recap some quadratic formula. So looking at our first example, when I'm looking at this expression, I see an x squared term, I see an x term, and I also see that c term. So that being said, I'm going to get everything over to one side to do some factoring. I'll look for those two numbers that multiply to my -20 and then that add to my -8. I'm creating those parentheses, right? Thinking about all of my factors of 20, and I'm thinking, well, 10, right? 10 and 2 will get me pretty darn close to that -8. So x minus 10 and then x plus 2, right? Checking those outers and inners, add to that -8, multiply to that -20. Set both equal to 0 and then solve. I get x is equal to 10 and x is equal to -2. There's no rounded value for that, right? We don't have to round to 10 or round to -2, and we're good. When we're looking at number 9, right, I see I have an x squared value, and then I don't even have an x value. I just have that constant. So we have a couple different options here. We can look to potentially factor. We can look to use square root method. Because I have that x squared value and no x, I'm going to try square root method. So I'm going to add that 100 on both sides, right? Isolate the x squared. 9x squared is equal to 100. Divide both sides by 9. We get x squared is equal to 100 over 9. Take the square root of both sides. X is equal to plus minus 10 over 3. So I have a positive 10 over 3 and then also a negative 10 over 3. If you factored that, right, because it is factorable, it would be a difference of perfect squares. So you would factor it as 3x minus 10 and then 3x plus 10. Set both equal to 0 and you get those two solutions. Don't you feel like you're just back in class because these things just keep erasing randomly? All right, let's go through our last example. Again, this is just like our last one. We can do a couple different things, but I'm seeing that I have that x squared value and then no x value. So let's add that 35 and use our square root method. Get that x squared by itself. Get that x squared by itself. X squared is equal to 5, and then take the square root. When I take the square root, I get both the positive and the negative square root of 5. So I have my two solutions, root 5 and then negative root 5. Rounded values, 2.24 and negative 2.24. All right. To finish it off, we have some quadratic formula, right? Identifying our a, b, and c value, and then plugging those values into our opposite of b plus or minus squared b squared minus 4ac all over 2a. So I'm going to write out that quadratic formula to give you some recap of that, and then give you guys the answers to those values. So let me write out that formula. I'll just write it out right here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to go ahead and pause the video, try these last 4 examples, and then compare those answers.